Alright, here's a bonus homework help problem. Let's work this one out. First thing, rational zero test, theorem says that we will make a list of all the possible rational zeros by taking the factors of the constant over the factors of the leading coefficient. So, first, make my pen thinner, and then take the factors of 4 over the first factor of 2, which is 1. So factors of 4 over 1, because the factors of 2 are 1 and 2. So factors of 4, plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1. Next, we'll take it over 2, plus or minus 1 over 2. Well, 2 over 2 is just 1, so we don't need to write that again. If I were to take 4 over 2, 4 over 2 would be 2, and so I would be a repeat as well. So just those 8, right? 1, 2, 3, 4 times 2, because each of those has a plus or a minus. So the way that I showed you in class, I said you could just plug these in for x and get 0, and that would be great, and you could divide, use long division, and all that stuff would work perfectly. It would be wonderful. But there is a quicker way. It's got its pros and cons. It's faster. The con would be that it relies on your memorization. It's very mechanical. It's kind of like FOIL, right? We all know how I feel about FOIL. I'm not thrilled about it. It's very mechanical. But this is very nice and useful, okay? So say I want to test the 0, 1. See if I plug in 1, will I get out 0? So the first thing I do is I start with this bracket and I put a 2, and then a 9, and then a 5, and a 3, and a negative 4. For the 2x to the fourth, and the 9x to the third, and the 5x squared, and the 3x, and the negative 4. And I'm going to plug in this number and find out, does it come out 0? And because it's a video that you can fast forward through this part, I'm going to show you why this works. I'm going to show you why this works, and if you skip over this, that's something you can do. I can't stop you. I'm going to show you why putting the thing that you want to plug in for x, why it comes out the way, that it comes out correctly. Okay? So first I bring down the 2, and the first thing I do is multiply this by that, right? 2 times x. So 2x. And I add these together, so I get 2x plus 9. 2x plus 9. So then I multiply x by that, right? So if I distribute the x to the 2x plus 9, that gives me 2x squared plus 9 plus 9x. And then I add 5. So I get, this is kind of tricky, 2x squared plus 9, plus 9x plus 5. And then I multiply this by x. So I get 2x to the third plus 9x squared plus 5x. And then I add these together, I get 2x cubed plus 9x squared plus 5x plus 3. And you can see what's happening. Like every time I multiply by this x, I am effectively getting this x to the fourth, x to the third, x to the second. So that's kind of a quick explanation of why this synthetic division, substitution thing works. Okay, so let's say that I want to not put x in there, but I want to put 1 in there. I'll plug 1 in and see if that works. Bring down the 2. 1 times 2 is 2. Add these together, I get 11. 1 times 11 is 11. 5 plus 11 is 16. 1 times 16, this doesn't seem like it's going to work very well. 3 plus 16 is 19. That's not going to work. 1 times 19 is 19, and this needs to come out to be 0, right? 0 remainder, 0 output. So, well, that didn't work. And if you think about it, if I try 2, it's going to be even worse, because what all was happening is I was getting this positive, plus positive, plus a positive, plus a positive, and it just kept multiplying by a positive. It just kept getting bigger and bigger. So I'm just going to kind of like use my deductive reasoning and say, I bet it's a negative number that needs to go in there, or maybe a half would work. I don't know, but I'm going to try these whole numbers first, integers really. So bring down the 2. 2 times negative 1 is negative 2. Add, we get 7. Negative 7. Add, we get negative 2. And then negative 1 times negative 2 is 2. We get 5 here. And it didn't quite work. We get negative 9. So that's out. Put this here. No. Okay, so negative 1 is out. Let's try negative 2. 2, negative 4, 5, negative 10, negative 5, positive 10. I don't think this is going to work. 13, no. So negative 2 didn't work. How about negative 4? 2, negative 8, 1, negative 4. This kind of seems good. 1, negative 4, negative 1, positive 4, 0. All right. Well, that's interesting. We kind of by our deductive reasoning, we said that these positive numbers aren't going to work. And then we actually did the work and found these negative numbers didn't work. We found negative 4 did work. So that means that x plus 4 is a factor, and we have to factor it out. Okay, so you might think, oh, let's factor x plus 4. We're going to factor this guy out. Maybe you have done this, and if you did, then I salute you. You have done good work. Okay. And you do all the division, and you know what you'll find? You'll find 2x squared plus x plus, let's see, 2x to the third plus x squared plus x minus 1 is what you'll find. And how do I know that? Because my synthetic division tells me that. 2x cubed plus x squared plus x minus 1. So x plus 4 times 2x to the third plus x squared plus x minus 1. And so now what do I do? Well, if you were in class and you watched me do number 3, you'll know that we're kind of at square one here. We have to do the rational zero theorem again. But if we do the rational zero theorem to try and find the zeros of this polynomial, our work's a little easier than it was in the beginning, because if I make that list of zeros for this guy here, for possible zeros, that's the factors of 1 over the factors of 2. That's only plus or minus 1 and plus or minus 1/2. Plus or minus 1, plus or minus 1/2. But we've already eliminated 1 and negative 1. Neither one of those could be zeros of this polynomial because they weren't zeros of this polynomial, and this is a factor of that one. So if 1 was a 0 of this, it would obviously be a 0 of this, okay? Because if this is equivalent to that. If I were to say 1 was a 0 of this polynomial, I could plug in 1 and it would become 0, and 0 times this would be 0, and this times this is f of x. So then it would be possible to plug 1 in here for you to get 0, but it's not. So 1 and negative 1, not going to work. So we're going to test 1/2 and negative 1/2. So let's try that out. 2 and 1, 1, negative 1. Put a half there. Let's see what happens. 2 times a half is 1. 2 times a half is 1. 2 times a half is 1, and we get 0. That was pretty easy. So we get x plus 4 times x minus 1/2 times 2x squared plus 2x plus 2. So at this point in number 3, we got to this quadratic, right? And then we factored it out. So let's try and do the same here. X plus 4, x minus 1/2. We come to the quadratic and we think, how would this factor? But we try to factor it. Like we do 2 times 2 and we get 4, and we say what we multiply to 4 and add to 2? Nothing. There is no possible way to do that. So we can't factor it. So what do? Let's back up a bit. Let's keep in mind what we're trying to do. We're trying to find all the zeros. What x's can I plug in that will give me 0 as the output? Well, if this times this all equals 0, then this must be 0, or this must be 0, or this must be 0. These are easy to solve. No new information here. We already knew this from our synthetic division. X equals 1/2, okay? this one, now we have this quadratic that we're trying to solve, a quadratic that we can't factor. How do we solve quadratics that we can't factor? The quadratic formula. I'm going to divide both sides by 2, just to start. Plus x plus 1 equals 0. And then use the quadratic formula. So I have negative b, that'd be 1, plus or minus the square root of b squared would be 1, minus 4 times 1 times 1 over 2 times 1. So we have negative 1 plus or minus the square root of 1 minus 4 is negative 3 over 2. So negative 1 plus or minus I root 3 over 2. So there are my other two solutions, my other two zeros. So here's a 0, here is a 0. Here are two other zeros. I found 4 zeros for a degree 4 polynomial. There we have it. We found them all. So there you go. Bonus video helping you out on that one. And this will be similar where we had to do the synthetic division here or plugging in and guessing at zeros 2 times. We'll have to do it 3 times here. All right, but that list of zeros is going to be pretty short, right? It's going to be factors of 3 over factors of 2. Not very many of those. That's it. Thanks for watching.